We've talked about maximum and minimums before, but this, because you have more than one, just a little bit different. We label the max and the min using the Y values. It's how low or how high the graph goes. Local max and minimums, these are found at the turning points. If it is a max, it's going to be at the top, and then a min is at the bottom. Okay, we know that from the quadratics unit. Absolute max or min is the absolute highest or absolute lowest point on the graph, okay? You will have an absolute when the function is even, okay? Only when the function is even will you have an absolute lowest point or absolute highest, because both ends are going in the same direction. Okay, if we look at this, this is what type of function? It's an even. Leading coefficient is positive. Just a quick reminder there, because it ends up, they both end the same way. Okay? So here's a turning point, here's a turning point, and here's a turning point. Does everybody see those three turning points? Okay, so this one here is a minimum, but it is a local min, because it is not the very lowest point on the graph. This is a local max, because it is not the highest, and I can't write local today with my pen for some reason. Okay, this one here is the lowest point, so it would be an absolute min. Okay, and we'll label them in a minute, but we're just talking about what they are right now. Does everybody understand the difference between the absolute and the local?
What's the other way?
Here?
Yes.
This is the local min. So it is a minimum, but it's not the absolute lowest. All right, on this one, it's an odd function. Just doing a little reminder. Leading coefficient would be negative. Okay, we have a turning point here, and we have a turning point here. With odd functions, you won't have an absolute, because the range is all real numbers, so it goes on forever and ever. So this would be a local max, and this would be a local min. Does that make sense? Okay, this one is even, and the leading coefficient is negative. We have a turning point here, a turning point there, and one there. So this is a local min, and this is a local max, and this is an absolute max, because it is the absolute highest spot. Okay, any questions about local versus absolute? Yes.
Is the local the same as relative one?
Yes. Does that make sense? Okay. Increase and decrease. Now this is where a lot of you are still struggling. Okay, and I told you in quadratics, if you're still struggling on this, when we get to these, because there's going to be more than one increase, more than one decrease, might not be good for you. What values do we use? X. So it increases as you move from left to right. Why left to right? Well, because left is negative, and we always read the graph left to right for X values. And what are we looking at on this? X values, okay? So where the graph is going up. Okay, so that's what we're looking for when we're increasing, where the graph is going up as we move left to right. Okay, was that? Oh, it's okay. Decrease as you move left to right. Always left to right because we are looking at X. Where the graph is going down. Okay. You will always begin with negative infinity and end with positive because you're going left to right. Now, if you struggle with this, I'm going to show you a way that is going to make it easier. Okay? If you look at this graph here, and you start here, and what is it doing first? Going down. Okay? So this point here is -2. So from negative infinity, she's not here. Thank you. So from negative infinity to -2, the graph is doing what? Going down. Okay, so that would be decreasing. So I'm just going to put a D beside it. I'm going to go in order with my graph instead of worrying about decreasing or increasing. Sometimes this makes it easier and then I can list it. Does that make sense? And now, when this turning point happens, I'm now going up. So what's happening there? So I go from -2 to 2, and what am I doing there? And yeah, it's about 1.5, but we'll say 2. Does that make sense? It'll be clear on your test. So at that point, I'm increasing. See, wherever you stop, you start with the next, right? Because as soon as it turns. Then what's happening after this turning point? It's going down, and now that's from 2 to infinity. So see how and this is decreasing. So see how I started with negative infinity and I ended with infinity. So then on your test, you would list the decreasing. So the decreasing would be negative infinity to -2 and 2 to infinity. And then the increasing would be -2 to 2. So does everybody see if you go in order, it sometimes makes it easier than trying to pull just the increase and just the decrease. Questions? All right, you do this one, and then we will talk. So this first part, I am going to be increasing. And the other thing you can do, you can write it like this, and you can say that's from negative infinity to -2 is increasing. Yes? And then I'm going down. So from -2 to, what did you put, a half?
0.5.
Yeah, that's what I would put. 0.5, I am decreasing. Good? And then here I am going up until 4, right? So that's increasing. So 0.5 to 4 is increasing. And then from 4 to infinity is decreasing. Is that making more sense than what it was in quadratics? Because some of you really messed that up in quadratics. Good? Good? So you can list them in order like this, or you can do like that. All right. Domain and range. Okay, domain is X. For all polynomials, the domain will always be all real numbers. Now remember, if we're talking about a real life application like that Pelican on the last, anytime it's real life, it's going to be limited. But if it's just a polynomial you're graphing, the domain will always be all real numbers. Okay? The range we use Y, and it is the lowest Y value to the highest Y value. Now we go over this. I think this is the 4th time we went over domain and range. It's because students really sometimes don't get it. So we're trying to make sure you get it, okay? So let's draw a couple little pictures here before we get this. If I have an odd function, my range will be negative infinity to infinity every single time because we read bottom to top. If I have an even function that opens up, I will have from the lowest number I know y'all think this is a pound sign, but it's actually number, to infinity. And it'll have a bracket there because it's included in the graph, right? If my function is going down, then it will go from negative infinity to whatever that highest number is every single time. Okay? So every single time. Any questions on that? Okay. Let's go down here and look. This is the function. What is the degree of this function? Look in here. 4. The degree is 4, so that's even. That means I'd have a maximum turns of 3 because it's the degree minus 1. All right, so the degree is 4. What do we know also if we're filling in this little box? What's my domain? All real numbers. I know that real quickly. My end behavior, they both go to positive infinity. Okay, looking at this graph, what are my zeros? X equals 0, negative 1, 1, and 3. And what is my y-intercept?
0.
0, 0, right? 0, 0. Good? Okay. We're going, huh?
Could that also be an x-intercept?
Yes, it is right there. X equals 0, right there. That is the x-intercept. That makes sense?
I was asking if the y-intercept also be the x-intercept.
It is, right here. See this 0 right here? That's the same thing. All right, so we're looking at this. Where is my maximum points?
No. 0.531.
Right here, right? This is a maximum. Is it a local or an absolute? It is a local, and where is that local at? It is at 0.941. You can list the whole thing, but normally it's labeled with the y part. Does that make sense? All right. Is there a minimum? Yes, we have a minimum here and here. Okay, so there is a minimum. There is a local at negative 1.383. And then there is a max, a local, sorry, not a max, not a max, an absolute, that's what I tried to say, at negative 6.914. Does that make sense? Okay. I want you to label your intervals of increase and decrease and you to do the range. And then we'll hop back. For the interval of increase, you should have got negative 0.67 to 5.31 because it is increasing right here and you use the X values. And then you should have also gotten 2.3 to positive infinity. Questions there? Decrease negative infinity to this 0.67 and then from 5.31 to 2.326. The range, this is the lowest point, so it would be negative 6.94 to positive infinity. Any questions on that?